Hello everyone, welcome to today's webinar. Today we're going to go over the most important topics in Unit 4. Unit 4 is the last unit in geometry. Before we start over the webinar, I'd like to introduce myself. My first name is Miriam. I have been here with Penn since October 2015. I am certified to teach high school math in the state of Pennsylvania since 2010, and I did earn my master's degree in 2017. Today, we're going to look at the elements that we want to learn how to identify in solids. We're not going to go over crazy type of solids. We're going to go over the typical solids that we may encounter in our life, maybe in our studies later on, like cones, cylinders, and stuff like that. So we're not going to go over the weird solids, but the kind of traditional solids that everyone who wants to maybe go to college or maybe pursue a career that deals with volume and lateral area have to know. Today also we're going to look at different formulas for volume, lateral area, surface area, and also we're going to learn how to calculate total area of solids. Today, we're going to specifically look at one of the challenging topics I think is the most one on that unit, which is the volume and surface area of a cylindrical ring, because that is not a typical solid, but it is part of our study unit. So we're going to focus on that one solid and try to gather what should we know about that one solid. Before we start over, we need to know the dimensions of solids. I just brought a cone here on the screen just for demonstration, but the idea would be the same for any other solids. So first of all, we need to identify the axis of a solid. So the red line that you just seen here on the screen would be the axis for these two cones. These two cones are different because the first one on the left is a right cone. I'm going to explain why we call it a right cone in a minute. And the other one, you can see it's shifted towards the right a little bit. If you look at the vertex, it's not upright. It's shifted to the right here. So we call it an oblique or non-right cone. So the axis would be a line. It's not a real line. It's an imaginary line that we need to know about the solid. And basically, it's the line where the solid rotates around. So think about Earth, for example. It has its own axis, and the Earth rotates around the axis. The same thing, you can think about solids that way. Another dimension that we need to learn for solids is height. So height is the distance between the vertex on the cone here and the base of the cone. Now the height is always perpendicular to the base, whether it's a right cone or a non-right cone. In a right cone though, you will notice that the axis and the height are aligned. It's the same line for right cones. So the axis is perpendicular to the base, and of course the height is perpendicular to the base, so they are typically the same line. And this is when we call a solid a right cylinder, for example, or a right cone or a right pyramid. Now with the oblique or non-right cone, you will see the difference here. The height is still perpendicular to the base, but the height and the axis, they do not meet. They are not aligned. They are not on top of each other. So there is difference between height and axis in non-right solids. Another dimension that we're going to deal a lot with is slant height. We're used to use heights in our solids, but in this unit, we are introduced to another height. It's the slant height. The slant height is connecting the vertex or the top base to the bottom base. And that line is a distance on the wall of the solid. So if you look on the right cone, it's connecting the vertex with the base. On the non-right cone, the same idea, the vertex with the base. Now, within this unit, we will look at different formulas for finding volumes, lateral areas, and total areas for different solids. So just to have the concept in our head, what's the difference between a volume, lateral area, and total area? So for example, most of us know the volume would be how much air or how much water you're able to fill a solid with. So that would represent the volume. And we always use cubic units for measuring volume. Lateral area is that if you think about the cylinder and you cut the wall of the cylinder and try to measure the area of that wall, that will give you the lateral area, like this. And finally, the total area would be the area of the wall plus the area of any bases of the solid. So a total area would be the lateral area plus the area of the two bases. If you have any questions, you're able to type your questions in the questions box, and please keep your questions relevant to the topics that we speak about. Also, I want to remind you that everyone, whether you attend or do not attend, you will get a recording of this webinar. Now let's go through some of the solids in this unit. The easiest ones you're going to see are the rectangular prisms or cubes and cylinders, because you may have seen these kind of solids before. And the formulas too are not that complicated. So for the volume, we're going to look at the prism or the rectangular prism on the left-hand side of the screen. You need to know the length, width, and height of the solid. So that would be the length, that would be the height, and that is the width. If you know these three dimensions, you can multiply them together. That will give you the volume, how much air, how much space inside that solid. Or if you need the lateral area, then you need to calculate the area for the outside walls of the solid. Now for the cylinder, it's the same idea, but the cylinder, because the bases are circles, you need to use the formula for area or formula for circumference if you need to find the volume or the lateral area. So the volume of a cylinder is the area of the base, the area of one base times the height. So if you have the radius of the base of a cylinder, you're able to use pi r squared to find the area, and then times that time the height, and that will give you the volume of that cylinder. If you're looking at the lateral area, the area of the walls of this cylinder, then you need to use the perimeter. The perimeter of a circle, or the circumference of a circle, is calculated by 2 pi r, 2 times pi times the radius of that base. And then you multiply the circumference times the height. That will give you the lateral area of the cylinder. Now, let's look at a question. This question is a self-check question. I feel that the formulas are pretty simple, so we can go ahead directly to a self-check questions. I did bring the formulas for volume and lateral area on this slide, so you're able to look at the question, work out the question, and then select your answer. In a little bit, I'm going to change my screen. You will have the same question on the screen, but this time you're able to select and submit your answers. So let's read the question together. What's the total area of a cylinder that has 9 meters height and a diameter of 4 meters? For me, whenever I'm dealing with geometry, I like to draw myself a little figure just to have an idea where those givens are on the solid. So it's a cylinder, so I'm gonna draw myself a cylinder. I'm gonna try to make it as perfect as possible. Okay, so the height, I know the height connects the base with the base, and it is perpendicular to the base, both bases, and it is 9 meters. And also in the same question, we know that the diameter, not the radius, the diameter is 4 meters. Now the total area, if you remember, it's going to be the area of the walls, the lateral area, plus the area of the two bases, since the cylinder has two bases. Try to use the formula for lateral area. And just to remind you that the area of a circle is pi r squared. Pay attention that the question does not give you the radius, it gives you the diameter. Do you know how can we get the radius from a diameter? So I'm going to pause for about a minute or something. You can work the question out, and then I'll change my screen and be able to, again, submit your answers. Okay, so again, the question is asking for the total area for the cylinder. Before I go ahead and change my screen, so the total area would be the lateral area plus the area of the bases. And we have two bases, which is, so area of bases, and our bases are on the shape of a circle. So we have two areas of the bases and then the lateral area. Add them together, that should give you the total area of the cylinder. So I'm going to change the screen now, and you'll have the same question. Enter your answers. And again, these questions are not graded. These questions provided to you here in this webinar, so you're able to assess yourself and see if you need to go back maybe to the lesson and review that topic. Here's the question. Okay, let's do the question together. So again, we're going to find the lateral area using the second formula that you see on the screen. And then, of course, we know from Unit 2 the area of a circle. So the lateral area here will equal to 2 pi r times the height, and then plus 2, because we have two bases, times, and then the area of one base, that would be pi r squared. It's always a good habit to write down the formula, even though we know it's lateral area plus the areas of the bases. It is always good to write out the formula. So the lateral area here and the bases are here, and we know it's 2 because the cylinder has two bases. The cone has one base, for example. So 2 times pi is 3.14. That is not changed. It's the same value for pi, times the radius. The radius is not 4. The radius is 2. Because remember, the radius is always half of the diameter. So r is 2. And then times the height of the cylinder, that is a 9. So I'm done with the lateral area part. Plus, we have 2 times pi again, 3.14, times the square of the radius. So the radius times 2 squared. Okay, let's evaluate the expression. So we're going to multiply 2 times 3.14 times 2 times 9, and that will give you 113.04, not yet done, plus the area of the two bases. So we're going to do 2 squared is 4, 4 times 3.14, and then times 2. And that will give you that the area of the bases combined is 25.12. Add the two values, and that will give you the total area of the cylinder, 138.16, and the units are in squared meters because we're talking about area, total area. So the answer in this case is C. Any questions of this one example? Anything that was not clear? Okay, let's move on to the next set of solids. We're going to talk about pyramids and cones. If you look at the study unit, you will realize that the volume formulas and lateral area formulas for pyramids and cones, they are similar. So for the volume, it is third times the area of the base, which is a rectangle or a square, times the height, and the height again connecting the vertex to the base, and it is perpendicular to the base. The same way for the cone. The only difference is that with the base in the pyramid, we are going to multiply the length times the width. For the area of the, or for the base of the cone, because it's a circle, we're not going to do the length times width. We're going to do the pi r squared to find the area, and then times height, and that is a third of all of these values. So it's the same formula, just a different way to get the area of the bases. The same way for the lateral area, half times the perimeter of the base times the slant height. When you go over the formulas for lateral area, you will notice that lateral area always speaks about slant height and perimeter. Volume always deals with area of the bases and the height. Let's take an example with the pyramid that we see on the screen. This question, if I'm not mistaken, is part of your study unit. So that is an example given within the lesson. So the question is asking, what is the lateral area of the right square pyramid shown? So again, with the questions, we need to extract the key words in the question. So the question giving us information that the base is square, and also it's a right pyramid, meaning that the height and the axis of this pyramid aligns. Well, the one I'm so concerned about and I want to use is the square pyramid. That means that the base is a square. Now, before we think what should we do, let's write down the formula and see what do we need in this formula in order to calculate the lateral area. So the lateral area would be the second formula from the box here on the top. Lateral area equals to the half of the perimeter of the base times the slant height. Let's see. So the slant height, we know that the slant height connects the vertex to the side of the base in a pyramid, and the slant height is right in the middle of that side. So that makes us realize that yes, the 5 millimeters is the slant height. So we know the slant height 5. The half is part of the formula, and then the perimeter would be the surrounding here of that square. Now none of the sides are given for the length. The length of those sides are not given, but there is a dimension here given. We know that the height goes through the middle of the base. So if the middle of the base is given as 3, that dimension that connects the middle of the square to the edge of the square is 3 millimeters. Then how long is a full side? Well, half a side is 3 millimeters, then a full side is 6 millimeters. And since it's a square, we're able to find the perimeter by multiplying 4, because we have 4 sides, times 6, because each side is 6 millimeters. Multiply these values together. So you're going to do 4 times 6, and then half of that, and then times 5. You can do the mental math, or if you'd like to use a calculator, you're able to do that. So at the end, you will find that the lateral area of this given pyramid is 60 millimeters squared. What about the volume? The volume of the pyramid is given by the formula V, volume equals to the third of the area of the base, not the perimeter of the base, that we know it's a square from the given, times the height, not the slant height. Okay, so third is just a value we have to use as is from the formula. Area of the base, we know that one side is 6, then the square, to find the area of a square of 6 millimeters as the length of one side, then we square the side length or multiply 6 times 6, the same as squaring the side length, and then times the height. Now, from the information here on that figure, we do not have the height given in the question, but we need the height to find the volume. Now, if you look closer to the pyramid, you will find that this triangle here is a right triangle. And I'm saying it's a right triangle because one of the sides of the triangle is the height of the parameter, the pyramid. So the height is perpendicular to the base. So it is perpendicular to that side that measures 3 millimeters. So that would make this triangle that I just shaded in yellow a right triangle. With right triangles, if you remember from Unit 2, there is a special formula that applies only to right triangles, which is Pythagorean theorem. The Pythagorean theorem, if you do not remember, speaks about the hypotenuse of the triangle. And it states that, let me remind you of the formula, c squared equals to a squared plus b squared. And that means that the square of the hypotenuse of the right triangle should equal to the sum of the squares of the other legs or arms of the triangles. Where's the hypotenuse? Again, we said that the hypotenuse always the side facing the right angle in that right triangle. So if I know the two sides, which is 5 and 3, I'm able to get the third side. So I'm able to solve the equation and find the height, which is I need in my formula. So let's fill in the information that we know from the triangle. So let's assume that 3 would be the A. Now B is the height, so that is unknown. C is the hypotenuse, which is given in this pyramid as the slant height 5 millimeters. Now we need to square the 5. 3 squared and B is squared. 5 squared is 25. 5 squared is not 10. It is 5 times 5, not 5 times 2. Same way, 3 squared is 9, plus b squared is the only unknown in this equation. With simple equation solving, we're able to isolate the b squared, which is our variable, by subtracting 9 and 9 from both sides. That's gone. It's a 0. 25 minus 9 will give you 16 equals to b squared. Now, I'm not looking for b squared. I'm not looking for the height squared. I'm looking for the height. So take the square root for both sides to eliminate the square on the b. So that will give you that b equals to the square root of 16. 16 is a perfect square, so the square root of 16 is a 4 millimeters. Now we know that the height is 4. All we need to do then is to multiply the three values. So 1 over 3 times 6 squared is 36 times 4. You can use a calculator or you can do the mental math again. So that will give you that the volume is 48 millimeters cubed. Any questions? Anything that was not clear in the work? Now, in this example, we did see that we used different formulas for the volume. When you have a question in the exam or the practice questions in your lesson, do not expect that the solution for that question would be through one formula. You may have to use different formulas. In this case, we did use the Pythagorean theorem to find the height, and then we used our original formula to find the volume of the pyramid. Next is a self-check question. The same idea. Since the pyramids and the cones have similar volume and lateral area, this time in this question we'll do the cone. What's the lateral area of a right circular cone with 16 feet height and 6 feet radius? So we're given the height and the radius. And in the question it says right circular cone. So that's why we have it drawn this way, the axis with a line with the height. We know the height makes a 90 degrees angle with the base, so it makes a 90 degrees angle with the radius of the cone. So let's put the information given so we're able to look at the figure more clearly and figure out how to find the lateral area, the area of the walls of this cone. So the height, which is this dimension, is 16 feet according to the givens, and also given the radius, not the diameter, only the radius. So that is 6 feet. We're going to use the lower formula here, half times the perimeter or the circumference of the circle, because the circle is the base, times the slant height. Do we have the slant height? Can we get the slant height? And also, what's the perimeter of this circle? I want to remind you the circumference of the circle is 2 pi r, and you have r. So I'm going to pause for about a minute. You can write down the question, draw yourself a little figure for this cone, put the givens and try the question, and then I'll change my screen so you're able to select your answer. Before I switch my screen, I want to help you a little bit because it's too much work for this question. So I do not want you to feel discouraged or that you cannot do the whole work by yourself. So let's write down the formula and figure out what's needed. Lateral area is half the perimeter or the circumference what we call it for the circles times the slant height. The slant height is the hypotenuse for this right triangle. We have the two sides, 16 feet and 6 feet, so we need the hypotenuse. I want to remind you of the Pythagorean theorem. C squared, the hypotenuse squared, should equal to a squared plus b squared. So we're trying to find the slant height, which is c in this formula. Fill in the information in this formula and find the missing hypotenuse, which is the slant height in this cone, and then you'll be able to use it in the formula. The perimeter or the circumference is given by this formula, 2 pi r, and r is given as 6 feet. Okay, let's change the screen so you're able also to select your answers. And here is the question. Okay, let's do the question together. Again, this question is a question that you, as you see, that you will use multiple formulas to find the answer. We're going to use the perimeter circumference formula for a circle. We're going to use the Pythagorean theorem to find the slant height. And then we're going to use also our main formula for the lateral area. So let's break it down. So we have half, that is part of the formula, is going to be used as is. The perimeter or the circumference of the circle, 2 pi r, and then times also the slant height. 2 pi r, that will make us do 2 times 3.14, 3.14, and then times r is given as 6. Multiply all together and you will find that the perimeter, or c, the circumference, it's going to be, let me do that real quick on my calculator so I'm sure of the circumference before we use it in the formula. So 2 times 3.14 and then times 6, and that will give us 37.68, and that is for the perimeter or the circumference part. So that is 37.68. Don't forget the half. And then our slant height would be the hypotenuse of this triangle. Hypotenuse is missing, so the c squared now is the variable that we need to solve for. A and B would be the sides of the triangle. So A, let's make that 16 squared plus 6 squared. Square the 16, so that is 16 times 16, and that will give you 256, plus 6 squared is 36. Add together, and that will give you the hypotenuse or the slant height squared, and that will give you 292. Since we need the slant height or the hypotenuse, we need to take the square root of both sides to arrive at c, and c equals to, of course, you're going to use a calculator to find the square root of this value, which is going to be 17.08 feet. So that will replace the s in our formula, 17.08. Multiply all these values together, and that will give you the lateral area of the given cone, and which is 321.79 squared feet. And that is answer A. Okay, let's move on to another kind of solids that you will see through your unit, which are frustums. In this unit, we're going to discuss the frustum pyramids and frustum cones. And frustums are basically a pyramid or a cone with the top part cut off from the solid. So that's why you see this frustum and this frustum. There is no top part for the pyramid or the cone. The same thing with the other solids that we did speak about. We need the slant height. We know the slant height, the pink line would represent the slant height. Also, we know the heights. It will be perpendicular to the bases in both cases here. And also there is another dimension that the unit gives you, and we will need whenever we are calculating the volume or lateral area for frustums. The dimension that I'm referring to is the side of this right triangle. The side, one side, or the hypotenuse of that triangle is a slant height, and then the other side will be the same height as the altitude or the height of the frustum. And then ED, this is how they label this dimension, the third side on that right triangle, we call it throughout the unit ED. So ED for frustum cones equals to the difference of the two radii of the cones. So ED, the length ED, equals to R2 minus R1, given that R1 is the radius of the larger base and R1 is the radius of the smaller base. That is for frustum cones. With pyramids, it's the same idea. We have an ED dimension, and this time ED for Frustum pyramids, it is half of the difference between the width of the major and minor bases. So if I'm going to call this width for the larger base WZ, and then the width of the smaller base, let's give it X and Y, then ED, the dimension here, that small side for the right triangle that we will need, maybe sometimes we have to use the Pythagorean theorem. So the side of that triangle is half of the difference of WZ and XY. The formulas, as you see, it's a little bit complicated with the frustums. You see square roots, you see fractions. We're going to have an example and see how we can do the calculations correctly. Okay, so let's take an example with frustum cones. What is the lateral area of the frustum cone with radii 4 centimeters and 7 centimeters and a height of 8 centimeters? Again, I think this question is part of your lesson. So after watching that webinar, you can go ahead and read the same example or practice question from your lesson and try to work it out yourself. Again, the figure is already drawn for us. Let's put the information on the figure so we know where to proceed from. So the radii, we know a frustum cone will have two bases. The smaller radius would go with the top base because that's the smaller base. So that is 4 centimeters. And then the larger radius would be for the larger base that is 7 centimeters. Now also we're given the height. The height is 8 centimeters. And that also would make us say that this side for this triangle, because remember the height is connecting the two bases, and this side too connecting the two bases. And in this unit, the two bases will always be parallel. So that makes us say that this side as well is 8 centimeters because these two lines will end up being parallel and they are start and end from the same points. Okay, so let's write down the formula for the lateral area. Lateral area for frustum cones equals to the slant height times the half of the sum of the parameters of the top and bottom bases. So circumference 1 plus circumference 2 divided by 2, and then multiply this value times the slant height. It seems that we're gonna use lots of formulas here because we need to find the parameter for each base that is using the 2 pi r, and then we need to find the slant height. We do not have this given in the figure. Okay, so let's start with the circumference of the circles. Since we know it's their short formulas, we are able to use them right away. So C1, let me do the calculations here. C1 equals to 2 pi R1. Let's call the top base 1 and base 2. So 2 times 3.14, and then times radius 1 would come from the top base times 4. And that will give you that the smaller base is 25.12 squared centimeters. I'm done with C1. C2 equals to the same formula, except we're going to use the second radius. So it's 2 times 3.14 times 7 this time. Do the calculations using a calculator, and that will give you that the circumference of the second base is 43.96 centimeters squared. Let's use the values on the formula. So far we have 25.12 plus 43.96, divide this by 2. We still have to find the slant height. Again, the slant height, it's part of a right triangle. We know one side 8 centimeters. Remember the dimension ED? This is ED, and ED equals to R2 minus R1. R2 was 7, R1 is 4. That makes us say that ED is 3 centimeters. So this side now is 3. Now we have a right triangle. Both sides are known. We need to find the hypotenuse. Then right away, we're going to use the special formula for right triangles, which is Pythagorean theorem. Let me change the color. So c squared equals to a squared plus b squared. C squared is the hypotenuse, which is the slant height we know or we need. So c squared is the unknown, equals to a squared. Let's say that a is 3, so 3 squared, plus b would be the height, 8 squared, equals to, so c squared equals to 9 plus 64, because 8 squared is 8 times 8 equals to 64. C squared equals to add. That will give you 73. Take the square root of both sides, so we're able to find the slant height or the hypotenuse if we're going to speak about the triangle. The square root of 73 is 8.5 centimeters, and that is the slant height that we need. So that would be then 8.5 times this fraction. How do we punch in those values on the calculator then? So we are able to have the right answer, the right lateral area. So if you have your calculator, we're going to do this. We're going to do 25.12 plus 43.96 equals 2, and then divide 2, and then equals 2 times 8.5, and then equals 2. And that should give you the correct lateral area. The lateral area for this frustum cone is 293.59 squared centimeters. Again, this question, we did use a variety of formulas, so do not limit your thinking or expectations to using only one formula. What's the volume of the same frustum cone? So again, the formula for a frustum cone says that the volume is the third of the height times the area of base 1 plus area of base 2 plus the square root of the product of area 1 and area 2. A common mistake for students that they do in the exams, that they add area 1 and area 2 under the square root sign. It's times, not addition. The additions are outside the signs. How are we going to do this formula? It looks scary because it has a fraction, it has a square root. So how can we do that? Step by step, we're going to find the area of the first base, the area of the second base, and then fill in the information, and then see how we're going to punch this formula with the values on our calculator so we can get the right volume of this frustum. So the area would be area 1 equals to pi r1. 3.14 times r1 is 4. So pi r1 squared actually. So 3.14 times 4 squared. So that is 3.14 times 16. And that will give you 50.24 squared centimeters. Okay, that is area 1. Area 2, same formula, pi r2 squared. So again, 3.14 times r2 is 7. So 7 squared is 49. Multiply, and that will give you that the area for the second base is 153.86 centimeters squared. Okay, we have everything that we need. So let's plug in the values. Volume equals to the volume equals to h over 3, that's 8 over 3, times area 1 is 50.24 plus area 2, 153.86 plus the square root of the product. So multiply 50.24 times 153.86. To evaluate this expression using a calculator, we're gonna start from inside out. So we're gonna multiply the values under the square root first. So we're gonna punch in 50.24 times 153.86 equals to, take the square root of the product and then plus 153.86 equals to plus 50.24 equals to, and then times 8 equals to, divide over 3 and equals to. And that will give you the volume. The volume would be, in this case, 778.72 cubed centimeters. Any questions? Anything that was not clear? Or anything that was different than what you've read in your study unit? I know that these formulas are a lot to learn, but with practice, you will get good on them. The more you do them, the better you will get at the calculations. Next is the masterpiece of this unit. It's the cylindrical ring. It's not the typical solid that we usually deal with, but it is part of our unit, and this is the hardest it can be. And to be honest with you, the unit is not explaining that too simple. So I try to put the figure together, try to put the labels for the dimensions that you see on the screen for the cylindrical ring, and then we are trying the next to solve a problem using the formulas for the volume and surface area for cylindrical ring. Just to mention, surface area is used like a term used for total areas for solids that does not have any bases. For cylindrical ring, then, we do not say total area, we say surface area. Same thing with spheres. We do not say the total area of the sphere, we say the surface area of the sphere. So before we go into an example for the cylindrical ring, let's look closer to the dimensions that we may need when we find the volume or the surface area for this solid. The first thing I want to say that the blue lines here are the walls of the cylindrical ring, and inside the ring it's empty, it's volume. And this circle here, it's not part of the cylindrical ring, but it's a ring, so it is a shape of a circle. Also, in these questions regarding cylindrical rings, you're always going to be given two dimensions: the outside diameter. So I use the same symbols in your unit, so you're able to go back and forth between this webinar and the unit without no confusion. So FB will be given in the question, and this is the outside diameter of the cylindrical ring. Also, another dimension that they will give you in the question is the inside diameter, EA. Now, with these two dimensions, you are able to find the diameter of the revolving circle. If you think of a cylindrical ring, you cut that ring with a knife, the thickness of that ring, think about the thickness of that ring as a circle. The diameter of that thickness is the diameter D, small d, that we're going to need in our volume and surface area. You're able to find the dimension D, small d, taking the half of the difference of the inside and outside diameters. Another thing that you will need in the formula is the circumference of the center circle. And the center circle, I did make it in green here. So that circle is imaginary. It's not something that you're able to touch or see. It's an imaginary line that is circle goes through the center of the cylindrical ring. So we need the circumference of the circle. Before we are able to find the circumference of the circle, of course, we need the diameter, the yellow dimension here, the diameter of this center circle. And the diameter of the center circle, I did give it a symbol as a CD, diameter of the center circle, because in the unit, they have some confusion between the circumference of the center circle and the diameter of the center circle. So I thought just to make up a new symbol for that, so we're able to distinguish between the two values. So the diameter of the center circle is the sum of the inside and outside radii. So if I have the inside and outside diameters, I can take half of each, and that will give me the inside and outside radii, add them, and that will give you the yellow dimension, the diameter of the center circle. And remember, the diameter of the center circle is not something that I use in the formulas up there, but it's an intermediate step that I need to get through it in order to find the capital D, the circumference of the center circle, which is needed for the surface area and the volume formula. And then from the diameter of the center circle, multiply that times pi, and that will give you the circumference of the center circle. And by having the little d and capital D, you're able to use each of the formulas to find either the volume or the surface area of the ring. Let's look at an example and see how are we going to use those formulas combined to find the surface area of a cylindrical ring that has an outside diameter of 10 millimeters and inside diameter of 7.5 millimeters. With cylindrical rings, I like to draw myself a little drawing, and I did not make it previous, so I'm able to show you how you can do that yourself. So it's a bigger circle, and then inside a little circle. So this is O, the origin. This is the outside diameter given. I'm going to keep the same symbols as the units so you're able to follow along. FB, so FB is 10 millimeters, that's given. And also given the inside diameter, which is I'm going to give the same name EA. So EA from the givens is 7.5 millimeters. Surface area, S equals to pi, 3.14, times little d, I need to find, times capital D. So little d is given by the half of the difference of the inside and outside diameters. D equals to half times FB is 10 minus 7.5. So do the difference first and then multiply times half. So the D in this case will give you 1.25 millimeters. So here I have D. So 3.14 for pi times little d, 1.25. I need capital D. And for capital D, remember, I need to do an intermediate step to find the diameter of the center circle. The center circle is here. It's an imaginary circle that goes through the middle of the center of the ring. And just to remind you that the little d was the diameter of the thickness of that ring. Okay, to find the diameter of the center circle from this formula, C and then little d equals to OB plus OA, which is essentially the sum of the inside and outside radii. I'm given the inside and outside diameters, so I'm able just to take half of each of these values, and that will give me the radii. So OB is actually FB divided by 2, and OA is the inside radius, then divide the inside diameter over 2, EA divided by 2 equals to FB is 10 over 2, EA is 7.5, divide that over 2, and that will give you 5 plus the half of 7.5 is 3.75. Add them together, and that will give you not the capital D, will give you only the diameter of that circle. So add them up, and that will give you 8.75 millimeters. Again, this is intermediate step. Intermediate. That's not one of the values I need in the formula. But from this, I'm able to find the circumference of the center circle. So using this value, I'm able to say, well, D equals to pi times the diameter. So pi times C little d equals to 3.14 times CD is 8.75 millimeters. Multiply them together, that will give you then the value of the circumference of the center circle that needed in both formulas. So multiply, and that will give you 27.5 millimeters. So D here is 27.5 millimeters. Multiply all three values on the surface area formula, and that will give you finally the surface area for this cylindrical ring, 107.94 millimeters squared. The next question is, what's the volume of the same cylindrical ring? I'm going to write out the formula and see if we have everything. Volume equals to pi divided by 4, and then times the square of the little d, times the square of the diameter of the revolving circle, times the circumference of the center circle, so times d. We have everything we need because we did find the values previously in the first part. So 3.14 divided by 4 times little d, we did find it out to be 1.25 squared, times the circumference is not the 8.75, it is the 27.5. Multiply, and be careful, you have to square the little d. So if you want to do that on the calculator, I would do the square first. So I'm going to do 1.25 and then square equals 2 times 27.5 equals 2 times 3.14 equals 2, and then divide 4 equals 2, and that will give you the volume, how much space inside that cylindrical ring. That would be 33.73 millimeters cubed. This is the most challenging topic, I think, in my opinion, in this unit. So if you're able to organize your thoughts and think about which formulas that you need, and find a way to organize your work when you do a problem, divide your paper or the page that you're working on, maybe use colors, and that will help you with solving this kind of problems. The last topic, I promise, for this unit, I just wanted to go over it real quick, no calculations. This figure, for example, is not a figure that we have like a certain formula that we're able to find the volume for. So the special thing about this solid, which is I called composite solids, that term is not in your unit. It's composed of 3 different solids that we know how to get the volume for. It's a cone, and the base of the cone is actually the same as the 2 bases of the cylinder, and then the base of the cylinder is the same as the width of the sphere. In your unit, there is a simple formula how to find the volume of a sphere. So if you're asked to find the volume of this figure, don't panic. Just find the volume of the cone, the volume of the cylinder, and then the volume of the sphere, add them up, and then that will give you the volume of this figure. And of course, if you're given that kind of question, you'll be given dimensions, like the height of the cone, like the height of the cylinder, the radius of the cone, and so on. That brings us to the end of the math part in my webinar. Today we did look at the dimensions of different solids axis, the slant heights, the height or the altitudes. We knew how to then define them on a figure. We also did do some problems about volume, lateral area, total area, surface area for different solids. Before you proceed to the exam, you are expected to read the unit. I mean, this webinar does not go through every single topic that you need to know for the exam, but it covers the most important ones. I should say, not the important ones, the more challenging ones that students usually want guidance on. But you need to read the unit, make notes, take notes, even if you have to use your phone to write some notes, or if you're a traditional person like me, very classic, I like to write my notes. You can watch the recorded webinars. Within your unit also, there's practice questions that are provided to give you some practice before you attempt the exam. Also, the answer keys are provided for those practice questions. They may be called self-checks or discover more questions within your lesson. But in all cases, the answer keys are provided. So they are provided because it's an independent study program. So if you do the questions, you want to make sure that you have the right answers before you go ahead and take the exam. So the way you do that is to work out the problems without looking at the answer key. After you're done, compare your answer with the answer key. If most of your answers are correct, that means that you are pretty much ready for the exam. If most of your answers are incorrect, please do not proceed to the exam, but find a way to reach out for help or watch this webinar or send your questions. How you can reach for help: you can call the school from 9 to 6 Eastern time on weekdays, of course. You're able to schedule an appointment with one of the instructors or teacher assistants on this topic. And also, you are able to text your brief questions to this number, and you can text learn, and that will come to our education department and will be able to help you with that. Another way to ask for help is to email your questions. If you have a detailed question, you want a detailed answer, then use email. If you have a brief question on an exam or a lesson, you can use chat. For these, you can access both features through your portal. You may have this look of the portal, and you may have this one on the right. They function the same way, we just change things around. So follow the instructions that corresponds to your account. You'll be able to email or also chat from your portal. And I would like to thank everyone who registered for this webinar, everyone who did attend. And there is a small survey. It's only 3 questions that will give me feedback on how I did throughout this webinar. If you attend or did not attend this webinar, you're able still to take the short survey and let me know what improvements I need to do or how I did throughout the webinar. I thank you, and I wish you all the luck in the exam.